Hello everyone! Today we're going to be talking about radians. Radians are a new concept in the further pure syllabus, and radians are a unit of angle, just like degrees. They measure the angle throughout a circle, or in shapes, or in any kind of things where an angle would be appropriate. They function in a different way to degrees in that there are 2 pi radians in a circle, and for a good reason too. While degrees are an arbitrary thing, they are just people deciding to divide one full rotation into 360 pieces, because that happens to be a number which is quite divisible. We are saying that 1 radian is, if you recall, that our circumference can be unrolled and segments which are equal to 1 radius can be marked, to leave you with a full circle being 2 pi radiuses. One of these segments on a circle, which is just under 60 degrees, one of these segments in a circle where the curved portion, the arc, is equal to the length of the radius, will always have an angle of 1 radian. Radians are written first with the number and then with a small c to the top right, rather than the O used for degrees, the degree symbol. For example, you know that one circumference has a length which is equivalent to 2 pi times the length of the radius. So you'll know that one full rotation is equal to 2 pi radians. On top of this, a quarter of a circle, for example, has a quarter of the circumference, c over 4, and as c is 2 pi times the radius, 2 pi r over 4 would be pi over 2r, or this length here would be pi over 2 times the radius, because it is a quarter of a complete circle. And so, since it is pi over 2 radiuses that make up this arc length, the angle here, which is a right angle, is known as pi over 2 radians. This pattern continues in a way that there is a linear way to turn radians into degrees and vice versa. At the start, you can use this kind of intuition to figure out values of radian angles from degrees. For example, take the fact that you know that 360 degrees makes a full circle, and 2 pi radians also makes a full circle. This is a colon here to show how the ratio is. So say you wanted to find how many degrees are in 1 radian. Well, you can divide both sides of the ratio by 2. And then divide them by pi again. So to get the number of degrees from the number of radians, you multiply by 180 over pi, because 180 degrees are in pi radians. To give you some context, 1 radian is about this angle. Furthermore, if you wanted to find the number of radians in 1 degree, you'll know again that 180 degrees is pi radians, or dividing both sides by 180, that 1 degree is pi over 180 radians. And that's because in pi radians there are 180 degrees. To give you context, a degree is an extremely small unit of angle, something like this, but yet smaller. This angle here is perhaps 2 or 3 degrees, if you can even call it an angle with this horrific triangle here. Alright, so some useful things to know about radians is that, so let's make a little table here, number of full circles, and then degrees, and radians. One full circle is 2 pi radians because there are 2 pi radiuses in a full circumference. It makes up 360 degrees. A half circle, for example, takes the half of all these values. A half circle has 180 degrees, whereas a half circle contains half the circumference, so half of 2 pi times the radius in length, so just pi radii, and so it's only pi radians. You can also get here by dividing this value of 2 pi by 2, just like how we divided this 1 by 2. So this is a full rotation. This is a half rotation. What about some other useful angles? For example, 90 degrees. It's a quarter of a full circle, and a quarter of a full circle will have pi over 2 radiuses on the curved portion, so it'll be pi over 2 radians. And then you can use similar logic for these other special angles, like 60, 45, and 30 degrees. 60 degrees is a sixth of a circle, and a circle is 2 pi radians, so a sixth of 2 pi is pi over 3 radians. Similarly for 45, which is an eighth of a circle, it's an eighth of the full circumference, or pi over 4 times the radius, and so an eighth of a circle is pi over 4 radians. And similarly for 1 over 12, it's a twelfth of a circle, and so it's pi over 6 radians. Now you might be wondering, why use radians instead of degrees? That's because in radians, it's a lot easier to calculate things like the length of this arc from an angle in radians. On top of that, it's easier to calculate the area of a sector, like the area of a slice of pizza, for example. If you're given questions in radians, try to use radians the whole way through. The same for questions in degrees. Converting from one to the other, I have never seen a question that required this. And so only answer in degrees or radians based on what the question gives you, with the sole exception of when they ask you to provide an answer in radians or degrees specifically. Once you get used to thinking in radians, with 2 pi being a full circle, pi being a half circle, and so on, the concept of radians becomes a lot easier to master. When I talk about special values of the trig functions, which you might have heard about, which for example are sine, cosine, and tangent, radians will be quite an intuitive way to figure out these functions, because their special values, unlike degrees, are simply fractions that you can use. With practice, radians become a unit of angle that you are able to use in problem solving just as fluently as degrees. In the next video, we'll be going over how we figured out the formula for arc length of a sector. Thank you for watching this video.